This is Dan Abbott. I teach at Southern Maine Community College in South Portland, Maine. I'm making this video to demonstrate a process for batch processing a large group of AutoCAD drawing and automating the process. This is a system that I developed in the early 90s and documented in a book I wrote called AutoCAD Secrets Every User Should Know. It's also the capstone project for our CAD management class. The students have to put together a process of automatically updating a series of drawings. But this example comes from a couple of graduates who came with a problem, and I worked with them to solve it, and it's just a good, really good exercise, a good demonstration of the value of this whole process. I'm using it as an example for my students and for anyone else who might find it interesting. So here's the problem as it was presented. This is one of the drawings, and this is an asset drawing. It shows it's a piping and ID drawing, and it shows one of the buildings, one of the pumping stations. And every asset is identified as a block. So this is a valve. If you double click on it, it shows you that it's got a number of attributes assigned to it, one of which is asset ID, which is the number that shows here, the TRV00652 number. It also has a facility ID, and it also has a process code. Back at in the server, at the main office, they have a large database, and that large database has information about every single asset that is keyed to three things: the asset ID, the facility ID, and the process code. All of those assets, all that information is something that can be accessed using an URL. And that means that if somebody had a hyperlink here and could hyperlink directly to that asset, they could just click on the hyperlink and then open up information about this asset and be able to use that information. So first, we want to add hyperlinks to all of these blocks. And we want those hyperlinks to specifically refer back to each one of the original URLs. The problem is that this is one drawing with 400 and some odd blocks, which means that you'd have to do this if you were doing it individually by opening every drawing, clicking, adding a hyperlink to it, knowing what the URL was, copying the URL, and bringing it over. The people who manage the database are able to provide a text file that has two columns, one with the unique attribute value for asset ID, facility ID, and process code, and the other a fairly lengthy URL. So that looks like this. If we open this file up with Notepad, we have a space delimited CSV file, and so the asset ID value with the facility ID and the process code is listed right here. Then there's a space, and then there is a very long URL that goes directly to information about that asset. So the trick is, how do we go about opening up this file, matching the information in this column with the information in that column, and then assigning the information in this column to the block with that attribute value so that it can be then used as a hyperlink. Beyond that, they wanted to be able to create PDF files and have the PDF files also contain the hyperlinks so that technicians and other people in the field who might be carrying a tablet that doesn't actually have AutoCAD on it, instead of having an AutoCAD drawing, could have a PDF file and could do the same thing. They could get there and say, we need to do some work on this valve, we need to know something about it. Click in the tablet, which would then be connected excuse me, to the database back on the server, and then they have all the information they need. It'd be a very efficient process. So that's the original problem, but it also introduces a number of other problems. One is, how do you put all that information together so you have a single attribute value that has both it has all three things: the asset ID, the facility ID, and the process code. Do you want to see a very long number here, which is now going to start getting in the way once you have, this is just one piece of just this one building. So do you want to have a very long number? Do you want to have the asset ID inside the building only showing on this particular drawing and on the PDF file? And that opens up a number of other problems as well. So what I want to do is to go through the process that we use to solve this. I'm going to open up the vlisp function and take a look at the list program that we wrote. This list program was written for locating code online. Mac's website had some useful code for us. An organization called cadtutor.net has a forum we found some data on, and then called CAD Kits, which I believe is in Australia, had developed something for sorting attributes, and I believe they also did the tag rotate and gave me permission to use their software. So this is, like most good list programs are, it's a compilation of all kinds of things, pieces of code from here and there, and then put together in a way that can solve this specific problem. Now the list program creates 9 new functions that are going to act as AutoCAD commands, and those functions are going to be called ultimately by a script. And what we did here is I separated each one of the functions into a separate command, and they're all listed here. If we go down through, there's a command called original asset ID, there's another command called full asset ID, and each one of these is separated to make them easier to troubleshoot, but then when we're going to use them, we're going to use them with a script file. The script file looks like this, where it loads the program itself, which then loads each one of those individual functions, and then goes through as though you're at the command line running each one. So that's one of the functions, there's another function, there's another function, there's another function, another one, another one, another one, another one, another one. So there's 9 altogether, and the script does what you would have to do with the command line, and some of them require that you select objects, so all is the option here, and then a space afterward. One thing just to remind you when you're doing a script, don't have any spaces at the end of any line, don't have your cursor end up here, don't have any spaces at the end of the file, and any open spaces you have here must be there only because you need to have an enter at that location. So we'll leave this out. I'm just going to minimize the list stuff. We'll leave this out so you can see what I'm doing. And just to go through this fairly quickly, let's just do it once with this much more restrained or a reduced version of the drawing. This is just one leg of the P&ID drawing. It has 4 blocks that are showing up. And again, just a reminder, each one of these blocks has variables, attributes, I'm sorry. They do vary, but they're actually called attributes. If you take a look, asset ID has the number that's shown, facility ID has its own number, and process code. Now these, by the way, are placeholders right now, because what I asked for was sort of a sample drawing. It's not exactly a completed drawing, but it's a sample drawing so that we could just make sure this process works. Well, the first thing I want to do is to add another attribute here, and I want to add another attribute because I want it to contain the value that's currently assigned to asset ID, because asset ID is going to be modified by string concatenating or combining asset ID, facility ID, and process code values into one. So original asset ID, first, it would be a good idea if I were to load the programs. So what I'm going to do right now is load the entire program, and you notice 14 forms, so there are a number of functions, and then there are a number of functions that act like commands. Now we'll come over here. So we have a command called original asset ID. So we'll run that. It asks to select objects, all, enter, enter. Now you notice everything sort of got funny, because what's happened is over time this drawing has had people manipulate it individually so that the attributes are readable. And that's because the blocks came in at very different angles, and sometimes the attributes came in at different angles. And so what I've just done is added an attribute which then puts the attribute values themselves back in their original position. If I double click on this, we're going to fix that. When I double click on this, right at the end, original asset ID has been added as an attribute and given no value. The reason I didn't give it any value is because we're going to give it the value here with the full asset ID function. I hate that nav cube, so let's get rid of it. Okay, so now the full asset ID command just created a new value and assigned it to the asset ID, but it also, before it did that, took the current value of asset ID, which is TRV00652, and assigned it to the attribute that was created in the last function, which was the original asset ID. So now we have a new value assigned to asset ID and a new attribute that holds the original asset ID so it can be displayed and seen. Now we're going to do a number of things that require that we go back into the group of attributes, and one of them is to assign hyperlinks. In order to do that, it's easier to do, from my point of view, if the very first attribute is the one you want. So I'm now going to do something called a sort tag. It's going to sort all the attribute tags alphabetically. Now most of them probably are already sorted alphabetically. Yeah, of these 4 blocks, all but one was already sorted. So it did sort the one that hadn't been sorted alphabetically. And now we need to synchronize all the blocks because we just made changes to blocks that have attributes in them, so we have to do an @sync. I'm not just going to do an @sync, I'm going to do @sync all, which is a program that I think I got from Lee Mack, I'm not sure, but it just synchronized all of these attributes. Now we're going to say, let's see if we can read those. So we'll do a tag rotate, bang. Now they're rotated so that they're all readable. They're not all horizontal, by the way. They're either horizontal or they can be read from the right, but none of them are such that they're upside down or can be read from the left. Now, I don't really want to see this longer name. All I want to see is this one because that's all that was in the drawing to begin with. And when these drawings get complex, which this small one is not, those longer names start to obscure some of the entities, the other entities. So now we're going to run the asset ID invisible. Now it's made that invisible, which means you have to turn @display on. If you want to see them, you turn it on and all the attributes are displayed, whether they were identified as invisible or invisible when they were first created. So now if we set it to normal, the only thing we're going to be able to see is the one that identifies what it is. You can also, by the way, as you probably know, you can turn all of them off. Turning all of them off really cleans things up. So we'll go back and set it to normal so we can see what it does. Now at this stage, what I want to do is to assign a hyperlink to each one. So just open up that VList program just briefly to show you what that involved. So now we're going to use a function called HyperPWD. And HyperPWD, which is, that's the sort tag. Sort tag is one of the longest ones, by the way. Here's another. Okay, this is also by CAD Kits. Let's see. @sync all. Okay, so the HyperPD. So what we're doing here is this. We're opening up that file I showed you that had a space delimited pair of columns. And it's going to open it and read line by line. And when it reads a line, it's now going to check to see, is in that line there a value associated with the asset ID for any of the blocks. So the while function here just loops through, looks at each block, compares the attribute ID value assigned to each block now to the very first column in that file. And if it finds that connection, it then goes on and redefines the attribute ID value so that it's a concatenation of 3 values. That actually happens down here. Okay, now we'll go back and do the HyperPWD. Now it does say, it does throw an error, but it throws an error after going through and doing what we wanted to do. And you'll notice if I hover over this now, there's a little link. Control right click, can't find the resource because I'm not connected to that database, but it was attempting to go and find that hyperlink. And if we look at the hyperlink that was added, it's that whole long URL that was in the column beside that particular number. Now, and then after that it does a save and creates PDF files. We're going to see those in a minute. What I'm going to do now is just to delete, or to just close this one. And go to the real drawing. Now the real drawing will do the same thing. We'll go to the VList function and load that whole program. Now we'll go through the process again. If we say original asset ID, pick all of them, it goes through and eventually 413 blocks. It assigns a new ID. It does the same thing it did before. It turns everything upside down. So now we'll do the full asset ID. full asset ID will assign a value to the original asset ID that we just created, and then it will create a new value for the old asset ID attribute. Do the sort tag. Everything, and now everything's been sorted alphabetically. In this case, we'll see how many of them need to do that. 493 are found, 133 are resorted, the others are already alphabetical. Then we'll do the tag row. Oh, no, we'll do the @sync all. Complete. So now it's all been synchronized. Now we'll rotate all the tags. Now they're all going to be readable. You can imagine doing all this, by the way, one block at a time. Now we want to make the asset ID invisible because we don't want to be able to see it. Now it's invisible, but we can always turn on attribute display if we want to see it. HyperPWD, this one's going to take a little while. It's going to go into that file. It's going to open up every one of those lines and read it. Compare what's contained before the break, before the space. And now it's done. So now if we hover over one of these, you can see it's got a hyperlink associated with it. And that hyperlink is that long URL. Now the HyperSave command is designed in order to save this drawing file, but not to replace the original drawing file. So what HyperSave just did was it created, go to the E drive, this is where we've been working right here. It created a folder called DWG, and then it saved this drawing in that folder. So that's the drawing itself with the same name, but it's been separated from the original by a folder, and as a result the original has not been affected, because anytime you're automating the process for updating drawings, the last thing you want to do is to discover to your horror that something went wrong, but you replace the original drawing. I also, whenever I write one of these for a company, require them to back up the drawings themselves as well. So I've got sort of the belt and suspenders approach here. They back up their drawings so that they've always got a backup, and I make sure I don't change anything in their drawing so that I don't have to worry about that. Now I'm actually going to delete that drawing folder, and I'm going to delete that drawing folder because we're going to automate this whole thing in a minute, and I want that to be empty when we start. Now, the PDF part about this. By the way, you might have noticed that there's a shell command here. The shell command is the external command created by the PGP file, and the shell command in this case is what allowed me to create that folder. The reason that that I use that is because I can create any kind of DOS function from the AutoCAD command prompt. But there's a problem, which is that sometimes that takes longer than AutoCAD expects, and AutoCAD then tries to retake control. So there is in the PGP file, start app, let me just open Notepad here and find file. What this is going to do is go and find the current AutoCAD PGP file in the path, and then it's going to open it in Notepad. In order to tell AutoCAD, don't wait. Don't immediately take control when we shell out. When we shell out, wait until things are done. Now you'll notice I have run this a number of times, and every time I run it, a new line is added at the end. That new line sets the bit flag from 1, which is what it's set for currently in shell, to 0. And the 0 just means don't retake control until the shell function is completely done. In fact, I'm going to get rid of all of those, and I'll save that again. By the way, if we look at the top of this, you'll notice that shell right now has a number 1 in the bit flag, and the bit flag descriptions don't even include a description of 0. The reason I know it's there is because at one time it was really critical that you manage memory in AutoCAD. I'm talking about 1988, 1989. And so a bit flag of 0 was a very commonly used bit flag. Why they don't have a description of it here, I don't know, but it still works, and without it, you're not going to do anything that has AutoCAD wait during the shell function until it takes over again. So I'm just going to save that, and we'll move on from there. So now we've got the hyperlink. We did a HyperSave. Now we'll do a create PDF, and the create PDF is going to open up every layout one at a time, and it's going to create a PDF file by plotting using the DWG to PDF plot file. Now normally when you do that, it opens up a preview of the PDF file as it goes. In this case, you notice it didn't do that. And it didn't do that only because I started by going to the plotter manager. And when I went to the plotter manager, I took the the plotter that we're using, the DWG to PDF is the one I use for this. Opened it up, went to Device and Document Settings, Custom Properties again, and I cleared the checkbox that says Show Results in Viewer. This program would still run if I hadn't done that, but I'm about to automate this, and if I'm doing 1,000 of these things, I don't need to have every single PDF file open up and stay there and show me as it goes through. So I'd like to just clear that out, close this up. Now I'm going to go back, I'm going to close this drawing file, and I'm not going to save it, and I'm going to close AutoCAD. So I'm now just clearing the deck a little bit. What I'm going to do is close everything other than Windows Explorer. Now in Windows Explorer I have on the E drive a folder where I'm putting all this stuff together, and one of the, let's get rid of that, this was all the PDFs went, by the way, even though we didn't see them opening, they were all created, and there are 6, there's 6 layouts in that drawing, so there's one created for each layout. I'll get rid of that. Now what I've got here is 4 different drawing files. It's actually the same drawing file that I was given as a test file, and I just duplicated it so that I have more than one drawing to open. Then I have this one test with 4 blocks. It's kind of limited. The CSV file, which is space delimited, is here. You have to know if it's space delimited or comma delimited, by the way, because when you write the list program, you got to write it in such a way that it goes up to the delimiter. So if it knows the delimiter is a space, it goes up to a space. If it knows it's a comma, it goes up to a comma. Now, in order to batch process multiple drawings in AutoCAD, and this is the process that I've spent a substantial part of a chapter in the book about. I've also, by the way, presented this at Autodesk University a number of times, and so if you were to Google Dan Abbott AutoCAD secrets every user should know, or maybe just changing hundreds of drawings in a hurry, you should be able to find it online someplace. Having said that, I think I'll pause and just see if that works. Yeah, I'm back. You can see what I typed here is Dan Abbott, changing hundreds of drawings, and the first thing that came up is something from the Augie forum, and that's a paper that I delivered. Wasn't in 2013, it was before that. Right, and come out of that. Now, there are 3 files that are needed to make this happen, and the first one's a batch file. If I edit that batch file and take a look at it, I'm using the DOS4 function, and that for function then assigns to what's called a replaceable parameter, which means it's a variable. Double %, by the way, because it's in a batch file. If you tried this at the command line, you'd use a single %. So it's saying assign to that variable the value found in this location, which is the E drive in a folder called Lucidity Test, and then the wildcard. So in other words, every DWG file is going to be assigned one at a time, alphanumerically, from the top to the bottom, to that variable. Once it's assigned, that variable can be used to do something to that file. Then it says do something. Start a program. But wait until the program's done before the DOS file takes charge. It's a little bit like the shell function in AutoCAD when setting it to 0. I'm going to have it do something, but I want it to be patient and wait until whatever I ask it to do is complete before the DOS file takes over again. And then what it's going to do is go and find this exe file, which is the AutoCAD file that starts AutoCAD. And if you feed the name of a drawing file to AutoCAD at the command prompt when you use the ACAD-EXE function to start it, it'll start AutoCAD and open that drawing. That drawing has quotes around it because drawing files sometimes have spaces. The quotes means it'll open it and see it as a single string where each quote is a character, not a delimiter. AutoCAD has a switch involved from the command line. Switch B means it's going to run a script. The script has got to be pointed to, and I put a script on the E drive in that same folder in a folder called Batch Update, and the name of that script is hyperlinkpwd.scr. Now that name of that script, when I do these, the name of the script file, the batch file, and the list file are always the same, just so I can keep track. It doesn't have to be. You can do whatever you want as long as you refer to them correctly. Good idea to put a pause at the beginning of your program. You notice a little menu pops up to tell you what it does, and then there's a pause. So that's the batch file. So that is the thing that opens up every drawing by starting AutoCAD. And we have a script file, and that script file gets run each time AutoCAD opens one of the drawings. So if we take a look at it, it loads a list program, HyperPWD.lsp, and then it runs the functions in that list program. And when it gets done running them, it quits out of AutoCAD, and the yes means yes, I really mean it. And then the list function itself, the list program itself, we saw. So I'm going to double click on that batch file, make sure I really mean it, press the enter key, and now I'm just going to sit back. I'm not touching the keyboard, I'm not touching the mouse. I'm watching it right now, but I could go off and have a sandwich or go home from work and just let my computer keep running. If you ever do this, by the way, make sure your computer is plugged into an uninterrupted power supply, because it's going to be running sometimes for a long period of time. So now it's doing all the things I just showed you to one drawing, and then it closes. Now going on to the next drawing, which has been assigned to that variable, that replaceable parameter, as DOS calls it. So now it's opening the second drawing. There are 5 drawings in that folder, so it's going to go through this iteration 5 times. Every time it opens up, it runs a script. The script does exactly the same thing. Now this process would only works if you're able to manage what's being done using a list program. You can actually, there are a number I've done without a list program, but the thing about the list program is it gives you a lot more options, because you got to do exactly the same thing to every drawing, but the list program allows that exact same thing to vary depending on the data that's in any given drawing that you open up. So this will be opening up, I don't know how many drawings they want to do this to, but it could be several hundred. Every time it opens a drawing, it'll have different block names, it'll have different configurations, it'll have all kinds of different things. It'll have some blocks that have an asset ID and some that don't. But the ones that have an asset ID are going to be treated in exactly the same way every time. You'll notice AutoCAD itself is opening, which means I can't use this computer while this is going on. I mean, I could conceivably use it to do some other things, but I would not. If I'm going to do this, I'm going to do it at night. I'm going to do it at the end of the week. Or I'm going to have a dedicated computer that does nothing but this, and then go on to use a different computer for other work. You certainly can't use AutoCAD because AutoCAD is otherwise engaged. There is something called the AutoCAD Core Console, and at one time when it first came out, I was quite excited because it allowed me. And by the way, the first one of these I did was I think in 1990 or 1991. And that was somebody who needed to do something to 4,000 drawings. Now this thing is all done. If I go over here to this folder, it created a DWG folder, and there are 5 files in it. And those files were, 1 minute apart, actually less than a minute per file. And it did all that work and then saved the result here without modifying the original drawing, without replacing the original drawing. Now every single layout in every single drawing was created with has a PDF file created for it, and so 1, 2, you can see 10 down through, well, they all get repeated because they're all the same drawing with just slightly different names. And then the test with blocks is also created. If I open up any one of these PDF files and then go and hover over it, you can see a little hand comes up. Now the only ones that have hyperlinks are ones that were listed in that database. So there's some of these probably don't have a little hand. There's one, okay, there's a hyperlink here, there's a hyperlink here, there's one here. There is nothing here, but you'll notice there's no, that didn't have an asset ID attribute either on that one, that block. So some of them do and some of them don't. That one doesn't, but it doesn't have the asset ID as well. If they have an asset ID, it probably has a hyperlink. But again, they gave me a sample database. That doesn't mean everything was in that database. So anyway, so far this has worked really well. Anyway, that's the description and an example of updating hundreds of drawings in a hurry. If you're in one of my classes, that's something to kind of look forward to when you take that class. Otherwise, for those of you that aren't in the class but think it might be helpful, you've got some resources. Go online and you can find that paper. If you follow that, I think you'll have a pretty good formula for doing it. I'm adding this short addendum to the video because I've made some changes since I made that video, and those changes were to improve the process by doing several things. One, now it is possible to start at one level, start at one folder, and then have AutoCAD drawing files updated in the subfolders in that folder as well as the folder itself. That's a change to the batch file, and I'll show you what that means in a minute. I also decided to compile the list program into an FAS file using the vlist compile function. It does two things. It makes the program run a little faster. It also gives you a file that is not editable, which means that people aren't likely to go in and make a change that might cause a problem to the file itself. In order to do that, though, I had to pull file names and locations out of the list program and put them someplace else, and I did that using the script. So if we open up the script file, a couple of things. One is when we come down here to the program called HyperPWD, where it is looking for a specific database file that has the asset ID in the first column, a space, and then the URL associated with that asset ID in the second column. I'm pointing to the location for the E drive in this case, and the folder, Lucidity Test in this case, and then the name of the file itself, the CSV file, in the script. So someone could change the script if they wanted to use a different location or a different file name. I've also defined a Lisp variable using Lisp code, which is why it's in parentheses. The variable name was output, and instead of having a specific location embedded in the Lisp program itself, output is defined as a variable here so that I can determine where I'm going to place all the files created. And those files that are going to be created are going to be placed wherever you have them go, but it means that it's also going to copy the entire folder structure so that the names of the PDF files that are created will include the name of the original drawing file, the name of the layout, and their location will mimic the folder structure that was in the drawings in the original, or used for the original drawing. The batch file change happened here. All right, for that, we have to change the way that the for function is used. And that just means a change in the syntax. And the changes have to do with a switch, front switch, or front/R, which means use subdirectories as well. The data is pulled out. The same kind of replaceable parameter is used, %%f. So it's saying for everything in this location and all the subdirectories under that location, go to each file name alphanumerically that has, and in this case the definition is every file with a DWG extension. After that it's pretty much the same, do start wait, which means it's going to go and start AutoCAD and wait for it to be done. All the change here is right at the beginning, so the use of the subdirectory switch requires a new syntax for the for function in the batch file. So let's run it. So I'm going to double click on this, hit enter, and sit back. And it's going to go through the process of opening AutoCAD one drawing at a time. This is going to take a little while actually, because it's going to do way more drawings. What I did was set up a folder structure that has multiple folders with multiple copies of the drawings in each folder so that it has some subdirectories that it can go through. Go through a few of these and then I'll pause the video, and when it's done I'll come back and show you what the result was. One of the things I might not have mentioned in the last video that I should mention is that in order for AutoCAD to open these without giving you a warning that the files themselves, the program files, are not in a trusted location, you have to add the locations to the trusted locations and options in AutoCAD. That just means you go to the options menu, go to the files tab. Under files, trusted location is one of the options. In any place where you're calling a script or a list program, but anytime you're calling one of those, what you want to do is call those from a location that's trusted, so you have to add that folder to the trusted locations. If it's not read-only, you'll get a warning saying it's not read-only. Just say, I don't care. You can see it's doing the same thing it did in the last video. What I'm going to do is to pause the video though, and then when this is done I'll show you what the results were. And I'm back, although it hasn't finished yet, because I'm going to actually go and look at the C drive and show you what it's doing. On the C drive, what it is doing is creating a folder called HyperPWD that was created today. You can see the number, the date. In there, there is a single folder at the moment called Lucidity Test. That single folder is the top level folder that contains the drawings. Open that up. Inside it is Lucidity Test 2, which is the next level folder that contains drawings, and the PDF folder, and all the drawings that were created by this program. Now those drawings themselves aren't even on the same drive as this, so there's no connection between these drawings and the originals. The originals are left behind. Go to Lucidity Test 2, and in that there's another PDF folder. That PDF folder has all of the PDF files created for those drawings, and eventually it's going to create another subfolder in here, so we're going to have an entire tree starting at the C drive with a folder that was created by the program, with another folder created by the program that mimics the folder structure that we used at the for the sources. Inside that is another subfolder. Inside that's going to be another subfolder when this is done, and now I'm going to pause again. Actually, I paused a little too quickly because there's the folder that was just created. Open that up, and so now we have a series of subdirectories that contain drawing files as well. When I ran this, I counted the drawings that were being processed, and these are all really just copies of the same single drawing that I was using as a test drawing, copied with different names and then put into different locations. There's 400 and some odd blocks in each drawing, and when I was done, I determined that at the rate it did the, okay, there we go. So now it is done. So now we have the entire folder structure. So again, we go back to the C drive, which at the beginning of this process there was no HyperPWD folder, created that folder, and then it's mimicking the structure from the source. So Lucidity Test was the top level folder, Lucidity Test 2 was the next level subdirectory, Lucidity Test 3 was the next level subdirectory. You can see it has the drawings that were created here, has the PDF files that were created here. We go back and every one of them has all these drawing files. If we take a look at the original source was here with Lucidity Test, Lucidity Test 2, Lucidity Test 3. So you can see it's mimicking that as it goes through. When I counted up the number of drawings that were processed and determined its average length of time that it took, which is about a minute, I think, and then did a little math, I determined that if you started this process running on a Friday at 4 or 5 o'clock in the afternoon, came back in on Monday morning, you could process over 5,000 drawings without having to have anybody actually be there, which, depending on the number of layouts in each drawing, would result in potentially 30,000 to 40,000 PDF files, all that have hyperlinks that didn't exist when you started.